When we're working with large language models, often, we're going to describe in our prompt a set of rules that we want the large language model to follow, rules that are going to affect its output, and essentially program the large language model. And one of the things that we're going to want to do, so we're going to want to say, here are the rules. Now apply them to an input that I'm going to provide later. And so one of the challenges is, how do we get the large language model not to immediately respond to all of our rules? If we have a flipped interaction, for example, sometimes when we flip the interaction and we say, ask us questions, it'll generate 10 or 20 questions all at once. And so what we want to, a way to do is basically a simple way that we can get the large language model to listen to what we're saying, acknowledge it, and then wait for input from us. Now we can do this with the ask for input pattern. So the idea behind this is we want to get the large language model to listen to the rules and then ask us for the input to apply the rules to. So, when we are talking about asking questions in a flipped interaction, we might want to describe the rules for asking the question, and then we just want it to ask one question. So we just want to get one question out. If we're describing rules for alternative approaches, we might want to say, here are the rules. You're always going to create alternative approaches to whatever I ask you to do, but just ask me now for the first task to create alternative approaches for. We don't want it to go and have a big response to it. And what we see is that that's not always the case. So let's take a look at this example. Now, in a prior video, I introduced the alternative approaches pattern. And when you saw me use this pattern, it worked really effectively because I was actually combining it with the ask for input pattern. So I'm going to show you what it looks like when I don't combine it with the ask for input pattern. So I went and I said, whenever I ask you to write a prompt for me to accomplish a task, list what the task is, list the alternative approaches for creating the task, and then write a prompt for yourself for each approach. So I'm asking ChatGPT, give me a bunch of alternatives for prompting you, ChatGPT, to solve the task. So this is going back to the earlier idea where I showed how we could actually use ChatGPT to generate prompts for itself to help us with prompt engineering. And what I do is I use this, but I'm taking away something important that I'm going to show you in a minute. And what it does is ChatGPT responds. It says, certainly, but then it dreams up a task. It says, here are 3 alternatives for completing the task organizing a cluttered desk. I'm not interested in the task organizing a cluttered desk. It just responded to my initial prompt, which was create alternative approaches for a task. It dreamed up a task and then dreamed up its own approaches for that task. Now I'm not interested in this, so now I've got my conversation and it's got all this extra stuff in it that I don't care about. I had to wait for it to generate it, and if I was trying to create some interactive experience that had some consistency, this would not be helpful. So what I can do is I can apply the ask for input pattern, and then the idea behind this is we just do one simple thing, and that is at the end of the prompt, we tell the large language model to ask for the next input. So in this case, we say, ask me for the first task. So the very last thing we do, we describe all the rules or whatever it is that we want in our prompt. And then the last thing we do is we said, now ask me for the first task. Ask me for the first idea. Ask me for the first thing you want me to generate a story about, whatever it is. But it's a way that we can sort of cut off the large language model and tell it, don't go generate a bunch of stuff. I'm glad that you can do that. But what I want you to do is I want you to stop right here and ask me what I want to do. So it's a way of forcing the large language model to basically turn the control back over to the user and let them decide what to do next. Now, like all prompt patterns, when we're dealing with a larger language model, it is somewhat stochastic or random. It means it's not always going to do exactly the same thing every time, and it may not work 100% of the time, but this works very, very reliably to just say, ask me for the first input, or whatever it is at the end of the prompt, because it clues the large language model and that it needs to stop. And if we look at the comparison of the output, It's actually much more focused. So we see in this case, it says, certainly, let's begin. What is the first task you would like me to create alternative approaches and prompts for? Rather than this much longer thing that it generated before, that was not really helpful to what we were doing. So it kind of cuts it off. Notice it's the same input, but it sort of cut it off. It's told it, look, you need to stop right here, and you need to wait for my input. A really interesting thing that we can do in a prompt is we can actually teach the large language model to follow a pattern using something called few-shot examples, or few-shot prompting. So the idea behind this is we're going to give the large language model examples of input that we would give it, and then the output that we would expect. And so you can imagine a human will go through a couple of examples. So they'll give it its input, they'll show it what the correct output should look like, they'll then give it another input, give it the correct output. And the idea behind this is that we're developing a pattern that the large language model can then learn to follow. So actually within our prompt, we're teaching the large language model a new trick. We're basically showing it what we want it to do and how we want it to format the output within a series of examples. So rather than describing the process we want it to follow, we're giving it examples of what we want it to do and then hoping that it will continue the pattern that we provide. So let's take a look at this. So if you'll see right here, we've got a simple example of few-shot prompting. So the idea behind this is we start off with input, and you'll notice that this is a common thing that you will see in few-shot prompting, is that you'll see a prefix applied to the lines. Now you can have all kinds of prefixes, and your prompts and your patterns don't have to just be input and an output. It could be a couple of different steps, and we'll look at that in a minute. But as we see here, we have an input, which is the movie was a bit long, and what we're going to do is we're going to do what's called sentiment analysis. This just basically is try to analyze some comment about a thing and trying to figure out what the user sentiment was about it. Like, were they positive about it? Did they think it was a good thing? Or were they negative about it? Did they think it was a bad thing? Or were they neutral? And we're just going to do a really simple example with sentiment analysis where we're going to take some, fake reviews of different things, and then we're going to decide if they were positive, negative, or neutral. So what we're doing, rather than saying, go and analyze these user comments and tell me if they are positive, neutral, or negative, instead what we're going to do is give a series of examples. So we give the first example, which was, the movie was it was good, but a bit long, and we say the sentiment was neutral. So it has some pluses and minuses. It was good, but it was too long. Then we have an example where we say, input, I didn't really like this book. It lacked important details and didn't end up making sense. And then we say the sentiment was negative, and then we have another input where we say, I love this book. It was really helpful in learning how to improve my gut health. And the sentiment is positive. And then what we do is we're going to give it the thing that we actually want to perform the task on, that we're going to hopefully get it to follow the pattern on, and we'll say, input. I wasn't sure what to think of this new restaurant. The service was slow, but the dishes were pretty good. And then we cue it in to follow the pattern by saying, sentiment. Basically, tell us what you think about this thing. Now, my prefixes are a little bit leading. They are giving it information about what to do, but it could also learn from these patterns. If we just said input and output, it can also do that, though I'm giving it a little bit of richer information. Now, my goal then is to get the large language model to go and analyze the input I give it and decide what should be attached as sentiment, and it picks up on our pattern, and it says neutral. So it sees it in this review, it says, service was slow, but dishes were pretty good. And so it's seeing that sort of positive and negative, and it's following my pattern that I gave it. I didn't tell it this is what neutral meant, but in the examples that I had before, a kind of a way balance of positive and negative ended up being neutral. Now, a couple things to note. 1, we didn't tell it what to do. 2, we didn't tell it exactly what the output should look like. And what we see is that it's constrained itself to the output. In basically the labels that we gave it earlier, we had negative, positive, and neutral. And it's automatically constrained itself, and provided an output based on that. Now, it won't always constrain itself, but this is a nice thing. As in many cases, this can help us get a more, constrained or bounded output out of it. Now, if we went and we gave it a new one, we could say input, I really hated this coffee. It was roasted too much and tasted burned. Now notice, I'm not going to give it the prefix for sentiment, so let's see what happens when I do that. And then you notice it provides the prefix and the output that I expected. Now, the really important thing to think about with this is, if you go back to when we talked about large language models and what they're doing, they learn to predict next word. They're learning patterns, and so when it sees input in a statement, it's predicting that the next word should be sentiment, because that's what it saw in the examples that we provided it. Before, when we ended with sentiment, then what it did is it knew that it needed to pick up right after sentiment. So if we go back to this and we edit it and we just add a line here and we say sentiment, then it should pick up the pattern right after sentiment. And so this is kind of helpful to know about when you're thinking about few shot examples. Now, this is a simple example of following a pattern, but you can see how this is a powerful way of teaching, particularly if you have data that describes the task that you want to do. When I say describes, it shows the input and it shows the output, and it doesn't necessarily describe how the task was performed, but we can see what's being done, and that type of thing can be a good fit for a few shot prompt. One thing that I find really helpful when I'm trying to learn a new topic or improve my skills 0012 Sarah, or just have fun, is to play a game. And when we can play games with new knowledge that we're trying to acquire, it's usually a fun way to really become masters of that knowledge and test our ability to use it, particularly if the games are fun and sort of challenging. And so one of the patterns that we can use is called the gameplay pattern. So the idea behind this pattern is we're going to ask ChatGPT or another large language model to play a game with us, and it's going to decide the rules. It's going to be the game master in most cases. Now, we can give it a variety of different sort of scenarios that can govern what its role is in the game, but we're going to look at gameplay where the large language model is serving as sort of the game master. It's creating the rules and it's driving the game. And so we can then take a game and we can say, I'd like a game on this topic, or that has these basic rules, fill in the rest. One of the things that's really nice about this is that if we say create a game and we give it some basic structure around the game, it can tap into its training data in order to populate the game with content. So if you think about games, like, getting the rules right obviously takes a lot of thought, but then there's a whole other challenge for a lot of games of how do you create a lot of great content to go with that game. And so this is a pattern where we can tap into the training data from the large language model in order to help it populate the content. Now, it can also do a pretty good job of deciding the rules as well, but we're not going to necessarily look in these examples at complex rule generation. But we are going to look at a really useful example of this, and I'm going to show you how to create a game to improve your own prompt engineering skills. So the basic pattern of this is to say, we are going to play a game, and we say involving or about or whatever, and we want to give it the topic. We start off this pattern by saying, we are going to play a game, and here's the topic. And then we decide some more information about what are the rules of the game. So in this case, we're going to have some simple rules. You're going to give me a simple task that can be accomplished via prompting you. So I'm telling it, we're going to play a game. You pick tasks where I could theoretically prompt you in order to solve that task. So you imagine what we're trying to do is have it play a game with us, where it's going to give us a challenge of something we would try to write a prompt for, and then we're going to write the prompt and see if we did a good job. And then we're going to say, your tasks should all have a reasoning or programming component to them, although they shouldn't require source code. Now, the reason I do this in this game is you get more interesting questions, in my experience, if you have some logical component to this. Remember, we talked about prompts as a way of programming a large language model, that everybody can be a programmer, and that's what we're trying to get at. We don't just want to generate a bunch of poems about lonely trees standing in the middle of a field. We'd like to do more than that. We'd like to have to solve problems that have some sort of logical or interesting component to them, and that's what we're getting at here with this prompt. So we're going to build a game. it's going to challenge us to develop different prompts. And then we're going to try to make these tasks that we're solving related to sort of programming or logical things. Now, next we go on and we give it some more rules. I will try to write a prompt to solve the task. You will give me the output of the prompt, and tell me how well it solved the task. So it's going to give us the task, and you notice we're having it ask us questions, so it's going to give us the task. The task is going to be something that could be solved with a prompt. We'll write the prompt, and then it will run the prompt in order to generate the output that prompt would have output, and then it's going to tell us how good our prompt was. So this is interesting. We're actually having it play a game where it's pretending to be prompted and then telling us how good our prompts are. Ask me questions until I tell you to stop. You will ask me a question, wait for my response, and then ask me another question, and after telling me how I did, ask me the first question. And so it says, great, let's get started with this first task. Given a list of numbers, determine whether the list contains any duplicate elements. If it does, return, yes, there are duplicates. If it does not, no duplicates found. So now we've got a specific prompt engineering task. We're going to have to figure out, how do we write a prompt where we give it a list of numbers and have it return one or the other of these things? And it's kind of interesting, right? This is one of the challenges that we often face when we're dealing with a large language model, is getting it to generate a precise output. And so it's giving us something where it has sort of a thought component to it of like, how do we design and tell it about what it is we're trying to achieve? But also, it's also got an output component. We're trying to match a specific output format. And then it says, please write a prompt for me to solve this task. So I'm going to solve this task using few-shot examples. So I give it a list of numbers. I show it some examples. I say basically, in my prompt, I say, here's the numbers 1, 2, 3, and then I have duplicates, and I say, no duplicates found. Then I have numbers 2, 2, 2, duplicates, yes, there are duplicates. And so I'm following the output format it told us, and then I'm going through and giving it a series of few-shot examples to solve this. And then I prompt it. My final end of my prompt is basically duplicates on the list I just gave it, which is solving the problem that it's asking for or trying to. We'll see what it says. But basically, I am asking it, does this list have duplicates? And we are hoping that what it says is no duplicates found and match this exact format that I provided before. And it does. It says no duplicates found right here. And then what's nice is it does the other part of the game that we explained. Your prompt effectively communicated the task and provided examples of different casts or of different cases. The task was to determine whether a list of numbers contains any duplicate elements, and you provided with examples. Based on your prompt, I was able to correctly determine the list does not contain any duplicate elements. And then it goes on, and it says, let's move on to the next task. So now it's playing the game, so it's moved on to the next task. Given a sentence, count the number of words in the sentence, and return the results in the format. The C sentence contains X words, where X is the number of words. So it's giving us an output that I have to produce, and notice it's giving an output now where I have to put the output in a different particular format. So before we just had to go and say, there's duplicates or no duplicates, but now we're having to do something a little more complicated. We're having to count words in the sentence, and then make sure the count shows up in a particular place in the output. This is exactly testing our knowledge of prompt engineering and some of the patterns and other techniques that we've seen in the past. Please write a prompt for me to solve this task. I'm going to use a pattern called the template pattern to do this. So, what we say is, I'm going to give you a template for your output. Number is my placeholder in all caps. Fill in my placeholder with your output. Please preserve the overall formatting of my template. My template is, and then I have, the sentence contains number words. So I'm going to solve this problem. Here's my prompt to go and solve this problem. And then I say, how many words are in the following sentence? The cat jumped on the mat. And it says, the sentence contains 6 words, which we see is exactly the format that it was looking for. And then it tells us. It grades us on our prompt. So what's really nice about this gameplay example is that from now on, you can go and use it to test your ability to do prompt engineering, And you don't have to think up what are prompt engineering tasks that I could try out. You can just use this prompt to have it generate the content for you. It can think up the ideas of the problems for you to solve with prompt engineering, and we can see in this simple example, it's already gone and tested some different dimensions of prompts for us and given us some opportunities to try out some different patterns. It then goes on and it gives in us another interesting one. Given a date in the format YYIMMDD, meaning year, month, the date, determine whether the year is a leap year or if not. If it is a leap year, the year is, YYYY is a leap year. If it's not. And so how do I solve this? I'm going to go through and give it some few shot examples, kind of similar to I did before, but it's testing my ability to figure out what do I do to solve this in this particular case, and then it gives us the right output that 2023 is not a leap year. Now, what's really nice about this is, remember, it's supposed to be checking our prompts and testing our prompt engineering skills, and I want to show you something that I didn't even notice until it told me and tested me. So I said, date 2009-07-24, so July 24th, 2009, and then I asked and then in my example I said leap year right here, and then I said the year 2004 is not a leap year. So my prompt example actually had a mistake, because I'm asking it if 2009, July 24th, 2009 is a leap year. And then in my example, I give it the wrong template. I say, the year 2004 is not a leap year. It should have been, the year 2009 is not a leap year. And then it actually notes that right here. It says, there is a small typo in the third example. The year 2004 is not a leap year. Should be, the year 2009 is not a leap year. But this did not affect my ability to understand and respond to the task. But it does give me feedback on my prompt engineering. It also shows me I need to be careful about the examples I'm giving it. If I make a mistake in my example, in this case, I got lucky and it didn't affect things, but it could in future ones. It then goes on, gives me a new one, which I didn't actually go and solve. Given a string of characters, determine whether the string is a palindrome. The string is a palindrome. So my prompt example actually had a mistake, because I'm asking it if 2009, July 24th, 2009 is a leap year, and then in my example, I give it the wrong template. I say, the year 2004 is not a leap year. It should have been, the year 2009 is not a leap year. And then it actually notes that right here. It says, there is a small typo in the third example. The year 2004 is not a leap year. Should be, the year 2009 is not a leap year. But this did not affect my ability to understand and respond to the task, but it does give me feedback on my prompt engineering. It also shows me I need to be careful about the examples I'm giving it. If I make a mistake in my example, in this case I got lucky and it didn't affect things, but it could in future ones. It then goes on, gives me a new one, which I didn't actually go and solve. Given a string of characters, determine whether the string is a palindrome. The string is a palindrome. If the string is not a palindrome, return, this string is not a palindrome. Replace string with the actual string. So it's getting a little repetitious in here, but we could go in and inject additional sort of ideas to help tailor the output even more. So you can imagine we might want to go in and target our prompt engineering a little more. Now, we've been learning a lot of prompt patterns in this paper. So one way we can adapt this game is we can give it a more specific topic about the type of prompts we're trying to develop. So in this example, I'm going to take the description of the recipe prompt pattern. And what's helpful is you can go to our prompt patterns paper, and you can actually take a little section or explanation of those patterns along with the name, and you can provide it into this game as context, and it does a reasonable job. If you provide enough information on the pattern and examples of asking you questions that would use that pattern to solve it. So in this one, I go and I actually modify the game and I say, all of your questions should revolve around the recipe prompt pattern. This pattern provides constraints to ultimately output a sequence of steps given some partially provided ingredients that must be configured in a sequence of steps to achieve a stated goal. The pattern is not about cooking per se. Now, I added this in here because I knew in my heart that it was going to want to ask me cooking questions, which, that's fine, but I've done enough of those. But creating a complete sequence of steps to achieve a goal given an incomplete list of intermediate steps. So I really want to use this. Cooking is obviously a natural way of talking about recipes, but I don't want it to clue in too much on that. I'd rather do some other interesting tasks. And so then it says, your goal is to create a prompt that instructs me to generate a sequence of steps for assembling a simple wooden bookshelf. The bookshelf has four main components: the top and bottom panels, the side panels, and the shelves. You have been provided with the following ingredients. Attach the top panel to the side panels. Insert the shelves into the designated slots. Using these intermediate steps, create a prompt that will result in a complete sequence of steps for assembling the bookshelf. Remember, the prompt should be designed to fill in any missing steps and provide a clear order for completing the assembly. Now, what's interesting is, this is kind of an interesting prompt because it has to have an understanding of a bookshelf and its structure. And you would have to go and write a prompt that's going to elicit the right problem-solving behavior on assembly of a bookshelf. So it's kind of a cool little problem. I then went and I took it and I said, all right, well, let's use another one of the patterns from the paper. And so I adapt and I say, we're now going to change the topic of your questions. The topic is now the context manager pattern. And then I'm basically providing the intent and context from the paper. And I'm saying, this paper or this pattern enables you to specify or remove context for a conversation. And I'm not going to go into the details. It did a pretty good job. It asked me a question about the Eiffel Tower and its construction. Then I went and I changed the topic again, and I said, we're going to change the top of the question. The topic is now the template pattern. And I describe what the template pattern is, and it actually does something that, follows what is exactly said in here, which is you might want to generate a URL. So we might get all URLs, so we might want to like tweak this a little bit, but it does a good job. It then gives me a task. Your goal is to create a prompt that instructs me to generate a URL for a product page on an e-commerce website. The URL should follow a specific template structure, and it gives me the structure, product.id/name. The product.id and product.name are placeholders that need to be replaced with the actual values, so you can see how I've got this game. It can test me on prompt engineering, so I'm learning about prompt engineering. It can actually give me helpful feedback. It caught a typo in my few shot examples, and then I can go and tweak it. I can say, okay, now the topic is, we're going to do a game based on this particular prompt pattern. Now we're going to do one based on this pattern. And what you'll see is you'll get interesting content that'll come out of it and challenges of things that you can try to prompt. Now, they may not all be good. They may not all be interesting. You may get in a rut where they're kind of like getting repetitive. But that is on you then to think about what additional information do you go and inject into this game to make it fun again or to make it more variable. I was pretty surprised at the quality of questions that I got, and it brought in a lot of topics. Like assembling a bookshelf is not one I would have thought about. That's certainly an interesting one. Or when it asked me about information related to the Eiffel Tower and its construction. All of these things are kind of bring fun to the game. Or is it a leap year or not? All of these things are kind of interesting ways. And all I did is gave it kind of the base rules and then the topic area. And then it pulled in all this information to populate the game with things that kind of helped keep me engaged, new content, new ideas to challenge me and make me have fun. And in this case, writing out the rules is a lot easier than thinking up all the content for the game, which it does really effectively. One of the most important things we can do in a prompt is provide the large language model with information that it doesn't have access to. So large language models are going to be trained up to some point, and then there's going to be a cutoff, and they don't know what's happened after that cutoff. In addition, they don't know things that aren't in their training set. So it may be trained on a lot of data, but it may not have access to data sources that you want to use. So if you're a business, for example, there's probably lots of private data sources that you would like to reason about. You have your own documents, you have your own databases, you have all kinds of things that you would like to pull information in from in order to reason about. So how do you do that if the large language model wasn't trained with that information? Well, to illustrate how you do this, I'm going to go back to an example that I provided earlier when I was talking about randomness. So I'm going to go back and I'm going to ask a question that I asked earlier, which is, how many birds are outside my house? Now, the large language model wasn't trained on information about birds outside my house. It has no idea where my house is. It's lacking information that it needs in order to reason. So it tells us, as an AI language model, I don't have the ability to perceive the physical world, so I'm unable to know what's happening outside your house. So how do we solve this problem? Well, we give it information it needs in order to perform its reasoning. And how do we do that? We just put it into the prompt. So anytime we want to go and introduce new information to the large language model that it didn't have access to when it was trained, all we have to do is put it into the prompt. So here's what I'm going to do right here. I'm going to say, historical observations of average birds outside my house on a random day. And then I'm going to give it some data. I'm going to say, January was 120 birds on a random day. February was 150 birds. March was 210 birds. April was 408 birds. It's March. Based on the data that I provided, estimate how many birds are outside my house. And now you see I've done something. I've given it information that it didn't have access to before. It couldn't look outside my house, didn't know where my house was. It tried to suggest ways that I could get there, but it didn't have the fundamental data that it needed. And that's really what it was trying to tell me, was like, hey, I can't see outside your house. I don't have that data. I can't help you. So all we have to do is up front in the prompt, we give it the data, and now you can imagine, you can do this with anything. You could take documents, if you have private documents that you want to reason about. Now first, make sure that you are okay sending that data to whoever you're using their large language model, or if you have some large language model, Loca, running locally. But if you have documents that you're okay sending, you could take the text of those documents and put it into the start of the prompt and say, here's the information you need to know. Now here's my question about that information. So you can use the prompt to introduce information. I really want to emphasize this because a lot of what's going to be developed around large language models is going to be taking new information sources, information about your travel, your account with some company, some other document that you need, and putting it into a prompt for a large language model so that it can reason about it. More than likely, lots of large language models are going to be seeing your information in the future, and this is how they're going to take it, is they're going to take information that's going to be aggregated into a prompt of some kind, and there's going to be questions asked or formatting or other things done. So when I go through and I provided historical observations of the average birds, now it can go and answer. So now it goes and it says, well, based on the historical observations you provided, the average number of birds observed outside your house in March is 210. So before, it said, hey, there's no way I can answer. Now it still, provides additional language around this, trying to, give some bounds on its answer, but it's giving us reasoning now based on the data we provided. And we can take it further, and I also wanted to just kind of point out an important thing is, we always want to provide it enough information to reason effectively. And so it can't see what's around us. It can't see the context, so it's really important that we provide it enough information to make sound decisions. So for example, if I have some hidden assumptions that are really important to know, it needs to get those in the prompt. In addition to the, data like, numbers, it needs to know the rules of the game, special things, whatever's important for reasoning. It could be not only the data, but it could be all kinds of rules that are sort of built into how my organization works or how my life works or whatever it is that it needs to know about. So I'm going to give you an example. I'm going to change up this prompt. I'm going to say, my house is covered by a glass dome. No animals can go in or out. All animals live forever inside the glass dome. Now, this is an assumption that this is something that if the language model doesn't know this, there's no way it will be able to accurately predict. But with this assumption now, it completely changes the game on reasoning because it sort of makes it so that it's clear some hidden fundamental rules. And then I go and I give it the same data, but I've changed it up and said it's always the same number of birds. And then I ask, how Based on that data, estimate how many birds are outside my house. And it says, based on the new information you provided, it appears that the total number of birds outside your house remains constant over time. It then goes on and says, you mentioned that all animals live forever inside the glass dome. Given these conditions, the total number of birds will remain the same throughout the year, and it gives 120 as the answer in multiple places. Now, one important thing about this, right? I'm giving it information that would not align with what it was trained on. Animals don't live forever. We don't have glass domes over our house. There's not going to always be the exact number, probably in and out, or the inability for things to leave or come. Like, we're not going to have these sort of weird rules that I put in place. And so if we just relied on it to reason without them, it's not going to necessarily get the right answer. So if we have these things that are different from the way things are normally done, we have to introduce them as new information in the prompt. So all of this information up here at the top, this is me putting new information into the large language model. We don't go and retrain. We don't go and, do some weird thing behind the scenes. We just put it into the prompt and then we ask our question or we ask for our output or give it the instruction we're looking for. Now, if you think about how search engines are probably going to work in the future, is they're going to go and search, pull documents back together, put them into a prompt to the large language model, and then give your sort of original question, and then answer based on the questions. A lot of new applications are going to be based on going and searching databases for possibly relevant documents or bits of information, putting them together into the prompt, and then asking the question or asking for the output. So an important piece of this is going to be pulling in information in order to put it in the prompt. And what we're doing is we are introducing new modlangu or new information into the large language model. We're doing it by putting it directly into the prompt. And this is one of the things you'll always want to do whenever you want to reason on new information that is not something that the large language model would have been trained on. I want you to think of ChatGPT and these large language models as tools that you can use to give your ideas form, to give your thoughts, realization, to be able to explore lots of different concepts and be able to refine them over interactions with the tool. I don't want you to think of these tools as something that you use to just write essays or answer questions. That's really missing the capabilities of the tools. These are tools that really allow you to do fascinating things. So now I'm going to try to give you an example of this to hopefully motivate you that these tools have immense capabilities and that those capabilities can allow you to do things that would be very difficult to do otherwise. So what is a task that I thought of that would be, something that we could all relate to? And I thought about my family, and I thought about this crazy idea. We have this great restaurant from Uzbekistan. That's in Nashville. We have a great restaurant from Ethiopia. We've actually got lots of great Ethiopian restaurants. And I thought to myself, what would it look like to create a meal plan that was based on a fusion of cuisine from Uzbekistan and Ethiopia? What would that look like? And in the past, I've eaten keto. So could we try to make it kind of keto? Because I still kind of like to limit my carbs. And, at the end of the day, realistically, I'm going to have to buy all the ingredients for this. And if they're not easily accessible at the grocery store down the street from me, I'm probably not going to cook the meals. So I thought, well, let's go to ChatGPT and see if it can help us with this problem, if it can help us prototype what this meal plan might look like. So I went to ChatGPT and I said, please create a meal plan for my family that is based on a fusion of food from Ethiopia and Uzbekistan. I want to eat keto and up to 2,000 calories per day. Pick dishes where the ingredients are easy to get from an average US grocery store. Now, this is a hard problem, right? I don't think that there's a human on the planet who could easily answer this question. And if they are, I probably could not find them. It would probably cost me too much to hire them, and they certainly couldn't do this as fast as I'm about to get it done for me. So I asked ChatGPT to do this for me, and ChatGPT says, here is a sample meal plan that combines flavors from Ethiopia and Uzbekistan, while also being keto-friendly and within a 2,000 calorie per day limit. Breakfast, scrambled eggs with sautéed onions, tomatoes, and Ethiopian berber spice. Now, notice what it does. It puts in parentheses. It says, made with chili powder, paprika, garlic powder, ginger, cumin, and coriander. Now, what it's signaling is Berber spice is something you can get at the average US grocery store. All of these spices are easy to obtain from a normal US grocery store. So not only is it answering my question, it's giving me an Ethiopian um, breakfast dish. It's giving me information that I'm going to be able to get these spices. Now, I don't know enough about Ethiopian cuisine to know if this is a really accurate dish. It may not be. It may be sort of inspired by it and very Americanized, but for me and what I'm trying to do, this is pretty impressive. Then goes on to say, lunch, Uzbek-style lamb kebabs with grilled vegetables, bell peppers, zucchini, eggplant, and a side of cucumber and tomato salad, dressed with olive oil and lemon juice. Now, you notice all of this is pretty keto-friendly too. Now, some people could take issue with the onions, but it's a really good first start of giving this crazy idea I have form. Now, it may have errors in it, it may not be perfect, but I could go and work with this and refine it and start improving it. And that's one of the things I want you to think about throughout this course is, don't think of this as a one-off. I give it a question and I look at the answer and I say it's good or bad. No. So I went back to it and I thought, well, one of the things that I'm really missing from this is I don't know how much to eat. So I said, can you give me an approximate serving size for myself for each dish that is within my 2,000 calorie limit? And ChatGPT says, sure. Here are approximate serving sizes for each dish based on a 2,000 calorie per day limit. Breakfast, scrambled eggs with sautéed onions, tomatoes, and Ethiopian Berber spice mix. And then it has, in parentheses, 2 eggs, half a cup of onions, half a cup of tomatoes, 1 teaspoon of Berber spice mix, served with a side of sliced avocado, 1/4 medium avocado. And it goes on to give me now serving sizes for each of these different dishes. Now, again, I didn't go and I didn't take it into like some calorie calculator and look at the macros and check if it really fit my diet, because I was just fascinated about prototyping this idea, exploring this concept, and I could keep refining it. I could keep looking and improving it, asking it to break down things, really analyzing and making sure it exactly fits what I'm looking for. But instead, I wanted to do something kind of different. I'm going to go and continue this thread of conversation, this crazy idea that I had, and give it a little more form. And so what I thought about is, if I was really going to take this crazy idea into my family, I'd have to think about my 9-year-old son. My wife and I are more adventurous eaters, but my 9-year-old, he's not always going to want to eat everything that we come up with. And so I thought, well, what could I do to help him get excited about trying these things out? And so I thought, I can go back to ChatGPT and I can try to get ChatGPT's help with this. So I said, ChatGPT, my son is 9. Sometimes he won't try new dishes. To make this culinary adventure more fun for him, can you create a short Pokemon battle story to go with each dish? And if you're not familiar with Pokemon, it's trading cards and a game and a cartoon. My son loves it. I will read the stories with him before dinner to get him excited about trying the new food. Make sure the story ends with a cliffhanger that will motivate him to try the new food. Now, maybe I could find somebody who could give me a meal plan based on Uzbek cuisine and Ethiopian cuisine, but and make it keto and do all those things and look it up. I'm not sure they could do it anywhere near as fast, but now we're really moving into territory where it's gonna be hard to find a single human being, and to get somebody to do all this is gonna be expensive, and I'm doing this in a matter of minutes. So what does ChatGPT say? Certainly. Here are some short Pokemon battle stories to go with each dish. And then we had the breakfast dish with the Berber spice, and it says, story, Pikachu and his friends were exploring the wilds of Ethiopia, and they were suddenly ambushed by a group of sneaky Pokemon thieves. And it goes on to have this Berber dragon that they're battling, and then it says, in the end, they emerged victorious, but not before the dragon left a fiery spice that imbued their breakfast eggs with a flavorful kick. Can you help Pikachu and his friends defeat the Berber dragon and enjoy this spicy breakfast? That's pretty amazing, right? We've gone from a meal plan to now help my son get excited about meeting eating this by mixing in some concept that he's really excited about, and it's actually produced a cliffhanger. Is this the best cliffhanger? Maybe, maybe not. But does it matter? No, because I'm rapidly sort of experimenting with my ideas. I'm trying to give my thought form. I'm trying to understand what this would look like, and I could go in, I could refine it and improve it further, but it's already done a pretty good job. I could probably take this and read it to my son and have him more excited about trying the dish. So then I thought, well, let's take this crazy idea further. So we're going to be sitting at the dinner table. We're going to read these crazy stories that ChatGPT has generated for me, um, to try to get my son excited about, eating these dishes. I thought, what else do we do at the dinner table that I could weave into this? Um, and I thought, well, one of the things we do is we talk about what my son is learning at school. And one of the things he loves is loves learning math and playing math games. And I thought, well, is there a way I can integrate that into this whole crazy idea? And I said, ChatGPT, I would like you to play a math game with my 9-year-old to teach him about division with fractions and nutrition. Ask him questions one at a time involving Pokemon and these topics, and make it into a game. When he wins, the Pokemon win. Ask the first question. And ChatGPT says, great, let's play a fun math game involving Pokemon and nutrition. Question 1. Pikachu and his friends are planning a meal that includes half a cup of cooked rice, but they need it. Need to divide it evenly among 3 Pokemon. How much rice will each Pokemon get? And it gives him a hint, and it says, if you get stuck, feel free to ask me for more hints, for guidance. And what does it do? It then waits for my son to respond. So we go and we type in the answer. We type in 1-6. Now notice before we were asking it questions, and now it's asked us a question. We've told it to create this math game. It's now asked me or my son a question. I'm typing in 1-6 as the answer, and now ChatGPT says, good job, that's correct. Each Pokemon will get 1/6 a cup of cooked rice. We got this answer by dividing 1/2 by 3, which gives us, and it works out the math for us. And so we went from, a meal plan, this crazy idea of a meal plan that's based on food from Uzbekistan and Ethiopia that's keto friendly that I can get at an average grocery store. We then added serving sizes or portions to it. We then took that and we got it to generate, Pokemon battle stories with cliffhangers that would help my son get excited about eating these dishes. And then I created a game, a math game based on nutrition and Pokemon to go along with this to make it even more fun. And then I thought, well, what else can we do this? I mean, let's really give this thought some form at the end. We've gotten the meal plan, we've gotten the stories, we've got this game. Can we give the game real form? And so I used some of my end domain knowledge as a computer scientist to say, let's create code for this. So we're actually going to produce software for it. So I said, let's create code for this in Python, but I want it to be a web application. And I'm not going to go through all the details because they are domain specific. They use my knowledge of computer science. But the key thing is that ChatGPT then generates actual software, the code for software for this. Not going through all of it, but the important piece of it is when we get to the end of it, we actually have real working software that I can run on a computer to play this math game with my son. And so you can see that we took some simple idea and we rapidly prototyped it into all kinds of different forms. And at any point in time, we could go and we could further refine one of the forms. So we could take the meal plan that didn't have, information about how much to eat and portions, and we could add that into it. We could reshape it into a completely different form. We could then eventually get to the end and take some form that we created and take it out of the language model and turn it into software. And so that capability of taking our ideas and rapidly iterating and prototyping with them, that's just one example of the type of thing that we can do with these large language models like ChatGPT. Now, I hope this example helps to get you inspired about the capabilities of what you're going to learn to do within this course. Patterns in our prompts can tap into powerful behavior within the large language model. It's trained on all these different patterns, and it gets really good at using the patterns in our language in our prompt to decide what it's going to do. So one of the important things that we're going to learn about is the concept of a prompt pattern. A pattern for structuring the words and the statements in your prompt. So what is a prompt pattern? A prompt pattern is a way that we document a certain structure of phrases and statements in order to solve a particular problem in with a large language model. So we'd like to interact with the large language model and we'd like to solve a particular problem. And so a prompt pattern is basically a way of structuring our statements, a pattern for structuring our statements to use the large language model to solve that particular problem. So what would be an example of this? Well, let's imagine that we wanted to consistently generate the words, lamb, its fleece was as white as snow. Well, a pattern could be anytime you need lamb, its fleece was white as snow, you can write the statement, Mary had a little. You will very consistently get lamb, its fleece was as white as snow as the output. And so, for example, we can go and we can rerun this. Lamb, its fleece was as white as snow. We get more or less behavior, but if we want to consistently get those next words generated, we can do it over and over and over again through Mary had a little. It gives us some control over the output. It gives us a consistent, somewhat behavior. Now, it's not perfectly consistent. There's variations in the output. And we've seen in all of these examples, we've got variation in what happened, but we did get some consistency in the behavior. So what a prompt pattern is it's a way for us to document and talk about certain structures of our language, series of statements and wording that then will help us solve some particular problem. If the problem that we need to solve is we need to get lamb, its fleece as white as snow as the next several words that are produced, then this is the pattern we use. Now, in many cases, we might have specific words we want. For example, we may want the large language model to tell us yes or no. We may want it to summarize something. We may want it to ask us questions. We may want it to always include certain things in its output. All of these things are problems that you might want to solve. We might want to know, how do we make sure it always includes these things in its output? How do we make sure that its output is always formatted a particular way? How do we try to make sure or get more consistent behavior on only getting a yes or a no? These are types of problems that you might want to solve by changing the pattern of our prompt, basically the structure of our prompt. Now, going back to our intuitive sort of understanding of prompts, you can see why thinking about it in terms of patterns is powerful, because patterns are basically that are in our prompt are tapping into things that the large language model has been trained on. It's been trained to predict the next word over and over, and it's learned certain patterns from the words. And if we can format our prompt in a way that taps into those patterns it's learned, we're more likely to get the behavior we want and solve that particular problem. So we document the pattern and the structure of our prompt in order to solve a particular problem that we need or generate a particular behavior that we need for the large language model. So we're going to go through in a series of lectures throughout this course of specific prompt patterns that we can use within the context of large language models to solve important problems. A really simple way to improve our interactions with a large language model like ChatGPT is to use the question refinement pattern. So this is a really, really simple idea, and hopefully it'll inspire other ideas from your patterns that you could use. But the basic idea behind this is that we want ChatGPT or another large language model, whenever we ask a question, to try to improve our question. So the fundamental sort of intent or idea behind this is that we may not have as much information or underlying thought behind our question as ChatGPT has from its training data. So it may be able to infer patterns and other questions or words or things that are useful when asking questions on this particular topic, or when trying to request something be done on a particular topic. So if you think about it, these large language models are trained on patterns and language. So if we give it maybe a more general question and ask it to refine it, it can use its knowledge of what other things are asked about in the context of the question we've given it, or what other words are typically associated with that type of question that might help improve our question, make it more specific, or provide additional context for other things. So sort of intuitively, what we're trying to do is we're using a sort of a general question, and we're tapping into the large language model's understanding of patterns and language around that topic of that question in order to create an improved version of it. Now, the The sort of pattern behind this is really, really quite simple. All we need to do is say, whenever I ask a question, or you can give it some scope to this, just for the next question or for the next 3 questions or whatever you want to do, you say something like, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is just a really simple idea. We want to always try to have the best questions, best prompts to interact with the large language model. So we'll simply tell it, whatever I do, ask, or suggest a refinement. Now I'm going to show you kind of a little tweak to this that's a really helpful tweak to know, which is we can say, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is kind of a nice little refinement that's sort of helpful from a user experience perspective, because what we're doing now is not only are we going to tell the large language model to create the question that's better, but rather than requiring us to go and, cut and paste it or tell the large language model, use the question that you just generated, we just have it say, do you want to use this question instead? And if we say yes, it uses that question. If we say no, it should use our original question. So it's kind of a nice little tweak to this pattern that can make it even easier to use. Now, every time we ask a question, the large language model will go and try to improve it. So let's look at an example of this. So I'm going to start off with a generic question, which is, should I go to Vanderbilt University? Now, if we look at this question, we can see it's really kind of, ambiguous and vague. And if somebody was asking you this question, should I go to Vanderbilt University? Or as a faculty member, if somebody was asking me, should I go to Vanderbilt University? Well, not only is this a big decision for the person, but there's really not enough information at this point for me to make a decision. So, a better question is going to help give me more information about the criteria that you're using to decide, do these types of, what are the pros and cons? How do you weigh them and decide if it's the right fit? And that's exactly what we see ChatGPT doing. ChatGPT says, sure, here's a suggested question. What factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities? And then it says, would you like to use this question instead? This is a really nice pattern because once we've sort of turned it on, we can begin asking questions and automatically getting better versions of our question. And one of the things that's nice about this is it also helps us to reflect on what we're asking for. And if we see a question come back like this, like, what factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities? Either we'll see that and see that's a really useful question, and that's how I really would have phrased it if I'd thought about it better, or more. But sometimes what we'll also see is that the path it's taking us down is not the one we want to go. And we'll realize there's lots of paths, lots of ways of answering the question, and we need to give some additional context. So not only is this useful in many cases of, getting a better question, but sometimes it's helpful to us to see that a question could be interpreted in many different ways. There's many different, pieces of information that may be needed to make an effective decision. And so by seeing one version of a refined question, we'll identify missing pieces of information. So for example, if I really care about computer science at Vanderbilt, I might think, oh, well, I should have mentioned that I'm planning on majoring in computer science. Or if the town that I'm going to be in when I go to, college is really important, then I might want to say something about, Nashville and living in Nashville. We want to make sure that you think through the question really effectively. And this is a pattern that can help us really hone in on producing better questions, learning from the refinements to the questions, and also using the questions, the refinements to understand what's missing in the context that we might want to introduce in order to get a better output. So, what does the word prompt actually mean? Now, we talk a lot about prompt engineering when we're talking about interaction with large language models. And so let's dive into this word a little bit because I want to give you a sense of the depth of what a prompt can be. It's more than just a question that you're asking to the large language model. So to do this, I think it's helpful to go through a couple of prompts and actually interact with ChatGPT to understand the concept of a prompt and sort of the dimensions to a prompt. So I started off here by just asking ChatGPT, what does the word prompt mean? And it comes up with some really helpful, I think, information for us to use when we're talking about prompts. One, it says it's a verb to cause or encourage someone to do something, to spur them to action. And it says, example, the teacher's reminder about the upcoming exam prompted the students to start studying. So part of what a prompt is, it is a call to action to the large language model. It is something that is getting the large language model to start generating output for us, basically to start generating words that will form the basis of our output. And those words could take all kinds of different formats. It could be software, defining the instructions in a program. It could be the words that we need for that. It could be words in a poem. It could be words in many, many different types of things. We could do it as structured data that we need. All of these things are possible, but the key is the prompt is basically our way of getting the large language model to begin to provide some output for us. The second thing it says is it's an adjective. It's done without delay, on time. And this is an important thing to think about with large language models is we're prompting them right now, do this. But this is also a useful point of discussion because a prompt doesn't necessarily, depending on how you work with it, have to be something that happens right now. Prompts can have time as associated with them, and now we have a little bit of an illusion of time, and I'll talk about this later in the course, but when we give prompts to the large language model like ChatGPT, the prompt could affect what's happening right now in my next statement that I give it, or in the current statement, or it could affect something in the future. And this is because of some of the conversational capabilities of these large language models. Now, we're going to talk about prompts themselves as conversations later on, but for now, the way to think about it is a prompt doesn't just have to be something that's immediate. It can be, but it doesn't have to be. The next thing it says is a prompt can be a noun, a cue or reminder that helps someone remember what they were supposed to do or say. Now, this is important because we can use prompts to remind the large language model of information or of things that it needs to do. And so we may be asking it to do something now. We may be asking it something to do in the future, in which case it needs to remember something. So we need to give it a reminder of what it's trying to do. We may need to go back and, give it a history of the conversation, of things that have happened, other things that will help it remember what it's trying to do. And then it can be another noun, a message or screen that appears on a computer or electronic device asking the user for input. So this is kind of a helpful thing because we can prompt the large language model to produce things for us, but the large language model, if we structure things correctly, can actually elicit information from the user. So the large language model can ask questions to us. So a prompt can both serve as a call to action or to spurring the large language model to action, or it can actually be an input. It can be asking us for input. So the last output from the large language model could have been a question for the human, and basically we are then providing information back to it. So prompts have a lot of different dimensions to them, and if you actually look at the definition of prompt, in fact, the definition that ChatGPT gives us, it gives us sort of that nuance to the capabilities of a prompt. Now, I've gone on a little bit here, and I'm going to give you an example of this time aspect to a prompt, because I think this helps to see the complexity and dimensionality of this concept. I'm going to say, from now on, when I ask a question, suggest a better version of my question, and ask me if I would like to use it. So right here, I'm starting off by saying, from now on. I'm attaching time to my prompt, so it's not just immediate. And we get a response, sure, I can do that. However, I will strive to answer you the original question to the best of my ability. And it goes on to try to reframe this original question, which wasn't what I necessarily needed. But then I say, what color is the sky? Now notice we're done, right? We asked, the original prompt was back here. I said, from now on, when I ask a question, and it immediately gave us a response because of that prompt. But now I'm going to ask a follow-on question. But the earlier prompt is going to affect this question. So right now, I'm asking it something immediate. What color is the sky? And it responds with, a possible better version of the question could be, what is the scientific explanation for the blue color of the sky during the daytime? Would you like me to use this version instead? And then I say, yes. Now, Notice here we have a lot of those different dimensions of a prompt that we talked about. Up here we are creating a prompt that isn't just immediate. It is going to affect us in the future. It's going to continue to influence the output of the large language model. So we can have immediate prompts that right now, right at this moment, do something, but we can also have prompts that span time. And in this case, that's what we're doing. We're creating something. From now on, go and do this. Would you like me to use this version instead? And then I say, yes. Now notice here we have a lot of those different dimensions of a prompt that we talked about. Up here, we are creating a prompt that isn't just immediate. It is going to affect us in the future. It's going to continue to influence the output of the large language model. So we can have immediate prompts that right now, right at this moment, do something, but we can also have prompts that span time. And in this case, that's what we're doing. We're creating something. From now on, go and do this. Now, we're going to have an immediate prompt, which is, what color is the sky? We're asking this right now. And now our earlier prompt that we provided that was spanning time is now impacting the way that the large language model responds to our questions. So now what's happening is it's taking our current immediate question, what color is the sky? But it's using the context that we had previously said to suggest better versions of all of our questions, and then ask us if we'd like to use them to generate its output, and its output is, here's a better question. What is the scientific explanation for the blue color of the sky during daytime? And you can see how that really is a better question than my first question. My first question was sort of vague, didn't provide enough context, and now it's giving us a more specific question that truly is better, and that's because of this prompt that we attached some time to it. We said, from now on, and so it's influencing what's said now. The other thing that we can see is we talked about a prompt being something that can elicit information from the user. And so now we are seeing that the ChatGPT, in this case, the large language model, is asking us for information. It's prompting us. It's soliciting information, and it's saying, would you like me to use this version of the question instead? So now we've got that extra dimension of a prompt. It's soliciting information from us, and we say, yes. And then it goes and answers the question. And it says, great. To answer your revised question, the blue color of the sky during the daytime is due to a phenomena called Rayleigh scattering, or Rayleigh scattering. And I apologize, I don't know this term, and I'm actually learning something from ChatGPT as I read this. The Earth's atmosphere is composed of various gases and particles that scatter sunlight in all directions. Blue light has a shorter wavelength and higher frequency than other colors, which causes it to scatter more easily in the atmosphere. The results? This results in the blue color that we see when we look up at the sky on a clear day. Now we've seen a lot of different dimensions to prompts through this short interaction. We've seen creating time prompts that span longer. We then see an immediate prompt that's spurring the large language model to action. We see the concept of the large language model prompting and getting input from us. And then we see the output of all of this. Now, one of the things to note is we also talked about memory, that the prompt had a source of a concept of sort of memory to it. And we'll talk about how this works in the future. But right here, I say, from now on, when I ask a question, that's something that the large language model has to remember in the future interactions, and we'll see how it actually does this. And so then when I say, what color is the sky? It's remembering that I said that whenever I ask a question, ask a better version of a question, and then it's responding right here with the better version of the question. And then if I go and I do this again, we'll see that it still remembers my original statement that it need to suggest better versions of my questions. So I said, how many countries are there in the world? And it says, a better version of your question would be, what is the current estimated number of countries in the world? And how is a country defined? Would you like me to use this version instead? And then I say, yes. And then it says, great. As of my knowledge cutoff in September 2021, there were 195 recognized sovereign states or countries in the world. However, this number may vary depending on how a country is defined. The United Nations, for example, has 193 member states, while other organizations and countries may recognize different numbers. Generally, a country is defined as a sovereign state with its own government, territory, and international recognition. Now, one other interesting thing that we talked about is that a prompt, has some memory associated with it. And this also shows us some of the limitations that the large language model's knowledge cuts off in September 2021. So one of the other things that we may need to do for the large language model is we may need to remind it of what has happened since it was finished being trained. And we can use a prompt to provide information to the large language model, like ChatGPT, about what had happened after it was trained. So we can also use it to provide information that the large language model didn't have access to when it was trained, like our own private information or other things. Now, of course, you have to be cognizant that when you're using ChatGPT or many of these other tools, you're actually sending information to their servers. So you do want to make sure that that is something you're willing to do before doing this. But if you're using a large language model locally on your machine, or you're willing to send the information, you can provide information that it doesn't have access to in order to reason about. So a prompt can also be about providing information to one of these language models. So if we look at this example and we say, what was Vanderbilt University's acceptance rate in 2020? It should have access to that. And so it provides this information. It says the acceptance rate was 9.6%. If we say, what was Vanderbilt University's acceptance rate in 2022? It'll say, I'm sorry, but it doesn't have access to that information because it was cut off in 2021. If we then provide it that information, so here I'm cutting and pasting the admissions data that was released and published by Vanderbilt just a few days ago, so it clearly didn't have access to this. If I now provide this to it in a prompt, then it says, based on the information you provided, it appears that Vanderbilt University's acceptance rate for the regular decision applicants of the class of 2026 was 4.7%. So a prompt can also serve as a way of providing new and updated information to the large language model like we saw in this example.